Hello, welcome to ChemLooms. This is Sarita. Today let us learn about one of the most important technique in chromatography, that is HPLC. HPLC stands for High Performance Liquid Chromatography. It is also referred as High Pressure Liquid Chromatography. This is the technique where we can use to separate, identify and quantify the components present in the mixture. So we can use this technique for the separation of the components. Then we can also identify, that is the nature of the components and also the amount of the components which are present in the mixture. The principle involved in this type is also differential migration adsorption. So the sample components adsorb differently on the stationary phase. So depending upon the adsorption power of different components, the separation takes place. So in HPLC, as in the name, it refers to as pressure. So here, HPLC, it is nothing but a column chromatography where we are applying high pressure in it. So in this again, there are two phases. One will be mobile phase, the other will be stationary phase. So the mobile phase is the solvents which we use are water, methanol and acetonitrile. These are the generally used solvents in HPLC. And we can change the nature of the solvents depending upon the sample what we are separating. Stationary phase. Stationary phase can be either silica or alumina. Now this silica, suppose if we are taking silica as the stationary phase, as it is polar, you can see here the silica where it is attached to a OH functional group. So this OH functional group is a polar group. So silica is a polar stationary phase. Now if we want to separate any polar components, we can take this silica as the stationary phase. That means the polar components will bind more strongly to the polar stationary phase, that is silica. And if we are taking polar as the stationary phase, then the mobile phase we have to take a non-polar mobile phases. So that we'll see the different types of HPLC later on in this topic. So when we need to take non-polar stationary phase, so what we have to do? So what we can do is we can add silyl groups. So in the next example, here the same polar functional group, actually it was OH. So this H we are substituting by the C18 carbon, which is having dimethyl silyl group. So when we take this silica gel and chemically bond with octyl silyl group or octadecyl silyl group. Octyl silyl group is carbon with 8, whereas octadecyl is with C18. So this is nothing but the CH2 groups, the carbons 18 carbons are there, and this complete thing is non-polar. So that is nothing but this silica, when it is bonded to octadecyl silyl group, it will act as a non-polar stationary phase. So we can have a polar stationary phase directly by taking the silica, and if you want to convert into non-polar, just bond that silica with the octacylyl group or octadecyl silyl groups. Then this is the general instrumentation in HPLC. So in this you can see that there is a solvent, okay, which is acting as a mobile phase. So this is, we call it as solvent reservoir. Solvent reservoir is used where the solvent is taken in it, and from this we need to pump the solvent into the column. This is the HPLC column. So this is high pressure is applied in this technique. So we need a pump where it is acting as solvent delivery system. So what this pump will do is, by applying high pressure, it will help the solvent to get into the column. So before the solvent enters into the column, there is a sample injector. That is, the sample from here you can inject the sample at this point. So sample is injected at this point, and even the solvent is coming at high pressure from the solvent reservoir. Now these two are then entered into the HPLC column. So where packing material, the packing material is nothing but the adsorbent that is acting as a stationary phase. So this column is packed with the stationary phase. Inside it, it will be there. Now when the solvent enters into this HPLC column, and the sample will get interacted with the solvent as well as the stationary phase. Later on, the separation takes place, and then the components are detected by the detector. So this detector is in turn connected to the computer system, where you can find out what is by this graph you can find out what is how many number of components are present, and what is the amount of the component also directly from the graph. And the detector, on one side, it is connected to the waste material. This waste is nothing but whatever the solvent is eluted out from the column, it is being collected in the big separating funnel here, which can be recycled back. So this is the general instrumentation of HPLC. Then we'll see in detail how the HPLC works. So HPLC is nothing but it is a modified column chromatography. This is in general if we take a column chromatography. So here the stationary phase acting, which is silica, alumina or cellulose. Mobile phase is run from the top. So due to gravity, the mobile phase runs down. But whereas in HPLC, high pressure is applied. Around 40 megapascals of pressure is applied. And the stationary phase that we can use in HPLC are, they are made up of very small particle size. So this silica, very small particle size, it is taken. So that means it will show larger surface area. When we have larger surface area of the adsorbent, we can have high resolution of the spectra, or that is the detector will do high pressure. Then if we go for the HPLC column, look at the column. So this is made up of stainless steel, and height about 5 to 25 centimeters. It has internal diameter of 4.5 millimeters. So this column, when the mobile phase is run down, the flow rate will be 1 to 3 milliliters per minute. That is, it slowly passes on to into the column. Then the stationary phase. Stationary phases may be adsorbent material. So same thing as I said, very small particle size. So chemically modified stationary phase can also be taken, that is silica or divinyl benzene. So this stationary phase, it depends upon the components which are present in the sample that you need to separate. Then mobile phase. Mobile phases are, they are stored in the solvent reservoir. They may be polar or non-polar. So solvent selection, again, it depends on the type of the sample. So depending upon the type of the sample, we need to select the solvents. So solvent may be a single solvent, or you can take a mixture of the solvent. Now the solvent is sucked by using this high pressure pump. It is injected into the column. So before injecting, as I said, there will be a sample injector where we can inject the sample. Then after that, after the sample has been injected, this column is connected to the detector. So it will detect the number of components. These are different types of detectors we can use: UV, IR, refractive index, mass spectro, electrochemical detector, etc., which is again connected to the computer. So direct readings can be obtained from the computer. Now how it works is, so now when the sample is injected, okay, along with the solvent is run. So this is how the components get separated, and you will get a peaks in the, and it is in the computer. On the x-axis we'll have time. So how this working actually takes place is, suppose if you are taking a standard glucose, so it is run, it is detected, and around 5 minutes the glucose will be eluted out. Suppose if you take another sugar, which is sucrose, it gets eluted out after 8 minutes. Now if we have a sample, unknown sample, and if we get If we run the HPLC of that unknown sample, suppose if this is the peaks what we get. Now at the 5 minutes of time, that is, it corresponds to glucose. So we can say that glucose is present in that sample. Whereas there is no peak at 8 minutes. So that means sucrose is absent. Only glucose is present, and the unknown peaks we can detect by the other comparing with the other standards. So this is how we actually find out the unknown sample present in the unknown sample through HPLC. Suppose if you want to find the concentration of the sample, what we have to do? So concentration can be found by the area under this peak gives the concentration. So all the three different concentrations of glucose is done. Okay. So after that, what we have to do is we have to calculate the area. More the concentration, more will be the area covered under the peak. So now this is the unknown sample. Now you can see the peak at 5 minutes. So that means it is nothing but corresponds to glucose, and the area under the curve will give the area of the that is the concentration of the glucose. We have different types in HPLC. One is normal phase HPLC. Now in this, as I said, stationary phase will be polar, mobile phase is non-polar. So when polar stationary phase is taken, the components which are polar will strongly adsorb onto the stationary phase. Therefore, only non-polar molecules will move down. Okay, because mobile phase is non-polar, so non-polar molecules will elute first. This is under normal phase HPLC. The other type is reverse phase HPLC. In this, what we do is just reversing the phases. Stationary phase is non-polar, mobile phase is polar. So non-polar compounds will adsorb onto the stationary phase. So along with the mobile phase, only the polar molecules will move down. Okay, so they will be eluted out first. Next is size exclusion HPLC, where it depends upon separation depends upon the size of the components. Here the stationary phase is nothing but porous bead. Okay, so all the small molecules will enter into the pores of the beads, only the large molecules will be eluted out first. So resin beads are taken as the stationary phase in size exclusion HPLC. Then ion exchange HPLC, where the ions are exchanged. Suppose if we want to separate the positive ions, you have to fill the stationary phase with the negative positive, that is the opposite charge. If we need negative, we need to fill with positive charged stationary phases. So the separation occurs based on the electric charges. So after this, what we can see is the applications. The applications of HPLC, we have number of applications in HPLC. So one is, it is used in both qualitative and quantitative applications. So qualitative is we can find the nature of the compound, and quantitative is we can find the amount or the concentration of the components present in the mixture. So it is also used in the separation of both cations and anions. It is used in forensic chemistry. Then it is also used in separation in lipids. Both polar and non-polar lipids can be separated. And also in the separation of steroids and hormones. And advantages, it brings about fast and efficient separation. This is among all the other techniques that we have studied, that is TLC, column, paper. This technique is very fast and it is also efficient. The results are very accurate. It provides continuous monitoring of column effluent. So continuous monitoring, suppose each and every component can be monitored. The separation of components can be done even for a very complex mixture, and it gives accurate quantitative measurements. So these are the advantages of using HPLC. So hope you have understood the technique, that is the principle behind HPLC. Thank you.